In this video, we're looking at ECAA 2020, Section 1, Question 7. So we have an equilateral triangle here, PQR, that's in a circle, and each of the vertices in this triangle touches the edge of the circle. We have a side length of 8, and we're asked to work out what is the circle's circumference. So first, let's start off with inputting some information we know about our equilateral triangle. What do we know about the lengths and the angles? Well, they're all going to be the same. So all of our side lengths are going to be 8 centimetres and all of our angles are going to be 60 degrees. The next thing to work out is what is our equation going to be for the circle's circumference? And that is 2 pi r, with r being the radius of the circle. So the thing we're looking for first is what is the radius? How can we find the radius? So let's draw some radius on here. So from each of the corners to the centre point here is going to be r. So this is the lines. We're going to try and work out what they are. So let's split it up into our smaller triangles here. How can we work out the side length of a triangle that's not a right angled triangle? Well, we can use some trigonometry rules. For example, let's use this sine rule here, which is going to be sine A over A, which is equal to sine B over B. So the sine of an angle over the length of the opposite side is equal to the sine of another angle over the length of the opposite side. So we can use A and B as our length we have here, 8 centimetres, and our R here. That's what we're trying to work out. So what angles do we need? We need the angles that are opposite these sides. So can we work this out? Well, yes, we can. We know that this in the middle here is a circle, so that's going to have 360 degrees. And if we're splitting up into 3 equal segments, that's going to be 360 divided by 3, so each one is 120. And that leaves these two sides as 30 each. And that gives us 180 all in this triangle, so these are 3 angles. So now we can input these numbers into our little equation here. So that's sine 30 over r is equal to sine 120 over 8. And if we start solving that, we have 8 sine 30 equals r sine 120. Now to make this easier, let's convert our sine 30 into a number that we can use just in our equation using our trigonometry triangles here. So we know that if we have an equilateral triangle with all side lengths 1, we can find the sine of our angle 30 like this. We're just splitting that in half. So sine is opposite over hypotenuse, so it's going to be a half over 1, which is just a half. So our sine 30 is a half. We can use this to keep solving our equation. We're going to have 8 times a half divided by sine of 120 is r, or r equals 4 over sine 120. So now we have our radius value, we can just plug that into our circumference. So that's going to be 2 times pi times 4 over sine 120, or 8 pi over sine 120. Now, this is a correct answer, but it doesn't look like one we have on our answer sheet. So let's try and convert this into something that looks right. So what can we do with that? Well, we can change this sine 120 into something that's equivalent. So let's look at a sine graph. Whereabouts would 120 be on here? Well, it's going to be around this point. And that is actually equivalent to this point here. So if 120 is here, that's 60 away from our 180 degrees point here. And so its equivalent point is going to be 60 away from our 0 point here, which is just sine 60. So sine 120 is equal to sine 60. We can convert that here to 8 pi over sine 60, which is one of our answers. It converts to answer B.